Now, when a disaster strikes, you should hopefully have invested in Offsite Storage, because that Offsite Storage library might be the only remaining copy of your organization's data. It's important to have controls over this data both physically and logically, meaning it's locked, it's secured, people can't get in, it's protected through the network, especially if you're doing remote journaling or some way of sending that information over the network. Now, the controls over the offsite storage might include, like I said, locking at physical security, properly constructed physical location, locating the library away from the data center. I heard stories about companies that in the days of 9/11 at the World Trade Centers where the offsite storage was the other tower, right? So we are talking about some significant distance away, especially in the case of fires, floods, natural disasters, right? If they're geographically separate, but not so much that it destroys your time of recovery, it's a help. So located away from the data center. Maintain the inventory of storage media files that are in the library. I would also say by the maintenance, test them out. Make sure you can recover. I've seen a company personally that lost over a year's worth of database information because nobody ever tested the backups, and they had to go back almost a year to find one they could restore. Ensuring that a record of the storage media and files are cataloged. Now, the types of backups and media devices should be chosen based on the standardization of technologies you want to use for the primary and offsite facility, the device's capacity, how fast they are, and of course the price. Your disk-based backup systems exist in different types. We have virtual tape libraries that are systems of disk storage and software to control the backup and data recovery sets. You have the host-based replication that is done at the server level, usually by special software running on the server. You can have a disk array-based replication, which is similar to the host-based replication, but done on a disk array, like a storage area network. And you can even take snapshots for those systems that support it. Now, both your data and your software files should be backed up on a periodic basis as defined by your recovery options. Your scheduling can be done by most backup management systems. The time period to schedule the backup might differ per application. Like I said, if it's a busy server, I might want to do a backup of the server, but not in the middle of the busiest part of the day, because sometimes it takes the server down to do the backup. The other things you have to consider is the frequency of rotation. You know, if you're, let's say, backing up to tape, it used to be we used to say, okay, how am I going to do this as far as the backups? Because, you know, it costs money to have a lot of tapes. So what do? We said, okay, let's do a full backup on Monday, all these other types of backups, another full backup, you know, and then on the end of the month, you know, we'll keep that backup, get rid of all the other prior full backups. I mean, we're recycling tapes. We call that rotating. And the frequency of the backup cycle and the depth of retention is something you should look at. The transaction files should coincide with the master files. Your DBMS requires specialized backups often. That's something to remember. Just because I do a server backup of Windows doesn't mean SQL is appropriately backed up. It's a different creature to back up a database. If you have custom-built software, you want to back those up as well based on what the vendor says that they should do. And if it's custom-built, make sure you get the object code and source code as well. Now, the backup scheme is something else you need to look at. Typically, a full backup is something where you just do that. You back up everything you select. And when you back up those files and those objects, they get their last backed up markings changed, updated. It's a little tag of some metadata. From there, you can do what's called a differential backup. Now, what happens is a differential backup is going to look at all of the files, and they're going to say, okay, I'm going to back everything up that has changed since its last full backup. So one of the little tags I said was the date that it was backed up. So there's another little tag on there that says date of last change. If the last change occurred after the last backup, I'm going to back it up. But I'm not going to re-tag it as being backed up. So I might have a few things that were changed since the full backup tomorrow. I'll have all those same things to back up again, plus anything else that's changed. And so over time, the differential backup will take more and more time. An incremental backup is going to back up everything that was changed since the last backup, but it's going to remark it as I just backed it up. So every day, the amount of change is all I need to back up. And of course, we have to have a method of rotation for those backups. The most popular is the grandfather, father, son method. And again, there's variants of that. But I might keep a full backup every week. And then at the end of the month, I keep that one, and the other ones I can reuse. So every week's backup I use over again. And then I've got all these monthly backups. But at the end of the year, I'll have just one yearly backup instead of all those monthly ones. So I have the grandfather, father, and son type of method.